Industries can benefit from automation. We can see that there are forklifts being used to get objects from high shelves. We can see that forklifts are really expensive. Jarvis store isn't. People have difficulty doing daily tasks. We can see that this person can't reach something from the higher shelf. Jarvis store can help that by being able to get something from the higher shelf and aiding them. We can see that also AI is really easy to use and really cost-effective to use in this day and age. We have created a smart gantry system that categorizes objects with a working cloud with 5 degrees of freedom that can move in practically almost any direction.
My name is Jason. I'm a rising senior at Northwest. I'm the lead of everything software related, and I'm in charge of making the web dashboard, the web server, and writing code for the microcontroller.
I'm John. I'm a rising senior at Winston Churchill High School. I'm the team captain and CAD lead.
I'm William. I'm also a rising senior at Winston Churchill High School, and I'm the mechanical lead.
I'm Ethan, and I'm a rising sophomore at Winston Churchill High School, and I'm helping with the mechanical and software.
My name is Marush Chaudhary, and I'm a rising senior at Northwest High School. I'll be assisting with the software. I'll be also doing the hardware, and additionally, I'll be doing the presentations and building the business card too.
We are Team Jarvis sort. So the problem that we plan to address is that a lot of people, for example, like they have mobility issues, or for example, they have like height issues where like things are like mounted on very high shelves and they can't reach it. This system is meant to help grab for them. It's a super configurable system that can be mounted on pretty much anything.
Basically, the general idea of this project is we need to be able to determine what an object is, and then this sorter will place it in the right spot. So the first step is obviously to find out what the object is. So we have a webcam which is connected to a Raspberry Pi, and whenever the user puts an item in there, it will snap a picture of that item. So the user doesn't need to give many images. They can just directly type in a sentence or two of what the object is, and then it will already be ready to categorize.
All the materials have been ordered, and that was a hefty process, and it'll be coming soon. And yeah, that's the biggest update and what was done this week, and we are awaiting for our materials.
The entirety of the CAD is finished, so we know exactly what our final product is going to look like. And that was instrumental in like our bill of materials, so that way we know exactly what we need to order and what we don't need to like save on expenditures.
So we already got much of the back side of the application done, and yeah, the categorization is done as well. So the next step I would say would be creating the actual web app. We haven't started doing that, but I think until really the actual clause like built, it would be kind of hard to test like the grabbing aspect of it. So that would probably have to be delayed by a few weeks.
So as we mentioned last week, we completely finished our CAD. And so this week we almost have all of our custom parts printed. So this is just like a skeleton of what we're creating. Yeah, this is really useful just to like make sure that everything works ahead of like printing using more expensive parts.
So we're waiting on our rails to come, which is a very important part of our gantry system. But our plan is to obviously first assemble the rails, and then from there you put the actuator and you put the end effector on. But for week 4, it would be all just assembling, pure assembling, hopefully praying that the parts come by Monday. And by the time we come back on Monday, everything is there.
This week, we finished nearly everything hardware related. We mounted the claw that we demonstrated last week onto our Core XY gantry. And so as you can see, it's super nimble, right? It moves super smoothly in these 2 axes. We mounted all the servos, those also arrived. So this is our 3rd degree of freedom. You can hear the servo spinning. And then right here we have our differential. So it can spin like this, so our roll. And then additionally like this, so our pitch. So that's all 5 degrees of freedom.
As for next week, on Monday, we're just gonna be trying to get every single thing on there on the finished system to move and like smoothly run. And then by Tuesday, we should have the claw being able to grab, and the entire system should be running smoothly. And then on Wednesday, Thursday, and Friday, it's just final tweaks, testing, and fixing whatever bugs may be remaining.
Our mechanic side is completely done. We implemented all of like the electronics, like the wiring, the motor drivers, everything. So this entire system right here, like this claw, We can remove this with 2 screws and attach any kind of interface that you would want. So like right here in my hand, I have like this magnet interface. So let's say we have this hanging on a pegboard, right? And we want to grab it. You can swap this claw out for a magnet using only 2 screws. And then you can pick it up like this and you can carry it around with the gantry anywhere you want.
So for the past 2 days, all we've been trying to do is connect everything. You'll see like this entire contraption here is the wiring we've done to get every single servo and every single motor connected to the Raspberry Pi. That's it. Just hopefully by today we can get somewhat movement in the gantry, and then tomorrow we can sync everything together.
It's definitely still to go because we have to do so much more testing. We got a better idea than just sorting and just marking it to just sorting objects. We're able to now grab any object and be able to do many things. So I think that we feel better about the reach of our project for sure.
I know this project was pretty ambitious. There are like so many different moving parts. There's like 5 axes of rotation. I think we're all very driven. And because of that, and furthermore, our teamwork, we were able to actually create a working prototype.
Good evening, everyone. We are Team Jarvis Sort. I'm Jason.
I'm Marus.
And we created a modular, flexible organization automation system, which is designed for flexibility and versatility. When proposing our project, we focused on a few key goals. First, it should have the ability to easily maneuver items no matter what type of item it is or how big it is. So we created first an end effector, which is kind of like either a claw or a magnet we put on the end, which is able to kind of point in any orientation we want. Additionally, what we call the gantry is able to move the claw in any position with precision and repeatability. Jarvis Sort can be used in many different applications, whether it be just simply in your home, reaching for a very high cupboard, or in a library where a librarian must sort many books, or even in pharmacies. There are many applications for Jarvis Sort.
And our future plans are to scale this gantry system into larger industries and larger shelves in manufacturing warehouses, in Amazon, in Target, in Walmart, in all these warehouses where this can be applicable. We ask the audience to help us have Jarvis Sort and diversify its reach to many industries. Thank you.